Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome to Macroeconomic study and thank you for joining me today. My name is Nur Hamidah and I'm delighted to present to you on the topic of economic growth analysis using the Solow-Swan model, technological progress, a case study of Indonesia's economic growth in 2019 and 2022. For the first, I want to tell you about the introduction. Economic growth clearly shows the impact of development policies implemented, especially in the financial sector. The problem of economic growth is seen as macroeconomic problem in the long term. From one period to another, the ability of a country to produce goods and services will increase. This is if it's based on and it increased ability to add factor of production, both in terms of quantity and quality. According to Tudor said, uh, economic growth has three factors. There is capital accumulation, population growth, and technological progress. The three factors that influence economic growth is called Solow-Swan model. What is Solow-Swan model? Solow-Swan model is economic growth model, which is the development of the Solow model previously discovered by Robert M. Solow from the United States in 1970, who developed the previous theory written by T.W. Swan from Australia in 1956. The Solow-Swan theory is different from the Solow theory because technological progress becomes an indigenous part of economic growth. After all, technological advance can expand people's production capabilities, which was previously considered an exogenous factors. In today's dynamical global economy, understanding the factor that influence economic growth has become increasingly important. The Solow-Swan model provides a solid foundation for analyzing how investment in physical capital, change in the labor force, and technological progress play a role in creating conditions that support long-term economic growth and how the economic reach a steady state. Indonesia has a dynamic emerging economy, faces unique challenges and opportunities in achieving inclusive and sustainable economic growth. Analysis using the Solow-Swan model can help explore the dynamic of Indonesia economic growth, including how change in economic policy, infrastructure, and innovation can affect the course of national economic growth using Python. Okay, for the methodology, I use two methodology that there is descriptive analysis to existing condition to review the Solow-Swan model, and then quantitative research to analyze the economic growth of Indonesia from 2019 to 2022 using the Solow-Swan model with technological progress. Okay, when we talk about the model Solow-Swan, so to incorporate technological progress, we must return to the production function when relating total capital, there is key, and total labor, there is L, and total output is Y. So we have different with Solow model and Solow-Swan model because Solow-Swan model we add another factor. There is E, whereas E is progress technology. And we have the term L cross E can be interpreted as measuring the number of effective worker. And worker can grow in two ways. The first is their number or total of the population, and then the second is efficiency, or we can call G. We have notation for Solow-Swan model R. There is output for effective progress, where is L we change with L cross E. For a capital for effective progress or production function, and saving and inflation for effective worker, we have a different formula, where is L we change with L cross E. So from the formula, we have general model, where is key star is investment minus depreciation, all right, for number of worker. For for Solow-Swan equation, we have investment minus population, and then minus technological progress, and minus depreciation. In other, we have the assumption that the labor total will grow constantly at rate and progress technology E at G. That's meaning effective worker will be great, will be grow at rate like this. We have E technological progress. Per E there is G, and at labor. Uh, Per labor is N. So we have the formula N plus G plus delta. There is we can get from this formula. Okay, when we talk about economic growth, so we can have steady state. In the Solow-Swan, we have the steady state, whereas will be obtained when there is a cut-off point or intersection between break-even investment and investment. So we can look in here. We have intersection between break-even investment with investment in key start, capital per effective worker. So the capital per effective worker we can call the steady state. The inclusion of technological progress doesn't substantially alter our analysis of the steady state. There is one level of key, denote key start, at which capital per effective worker and output per effective worker are constant. As before, the steady state represents the long run equilibrium of the economy. So from the figure, we have several steady-state conditions in the Solow-Swan model as written by N. Gregory Menke et al. In 2015. Namely, we have for condition, there is the variable in capital per effective worker. The symbol we have keep is P per L times E. The steady state growth rate is 0. And then we have variable output per effective worker, and symbol is Y, is Y per L times E. So the steady state growth rate is 0 also. Next, and we have variable output per worker. So the symbol here is Y per L is Y times E. So the steady state growth rate is G. There is growth as big as G. And then the last is about total output. We have the symbol in here is Y is Y small times E times L. Whereas the steady state growth rate is N with the population plus G with the technological progress. There is a population growth and technological progress. So after we talk about steady state, for the next step is we have golden rule. In the Solow-Swan model, there is a golden rule, namely where the steady state condition with the maximum consumption position is the golden rule condition is obtained marginal propensity to control consumption when we said MPK minus the break-even investment BEE is zero. So we can have marginal propensity to total consume is break-even investment. So in the golden rule, it is that the marginal product after depreciation is equal to the growth rate of the total output. So next is about the study case. Indonesia economic growth in 2019 to 2022. The case study in this journal is to look at economic growth in Indonesia for the period 2019 until 2022, where data is taken from several sources such as BPS or Badan Pusat Statistika, Kadin, and etc. to fulfill the variables needed in modeling the Solow-Swan model. The calculation uses the Python application to help facilitate calculation using computing so that the results obtained are more effective. So the result of calculation, we have the table 2, calculation result of the Solow-Swan model, and we have total factor production, or we can say technology progress is in 2019, we have 0.1, and then 2022, we have TFP is minus 0.9, and 2021 we have total factor production is 0.068, and then for year 2022 we have total factor production is 0.1. And then we can look for the table output per worker and capital per worker. The result is like this. After that, we can look for the graphic. So we have the graphic for progress technology or total factor productivity. We can see in the graph that in 22, Indonesia experiences a decrease in technological progress or total production factor. This is because in that year, the world was experiencing a COVID-19 outbreak, which also had an impact on Indonesia economic growth in the technological progress factor. And the second, we have graphic for capital and output per worker hour. There is the data analyzed obtained for the result of output per worker is that although Indonesia experienced a decline in 2020, in the following year it shows significant positive growth. So from the calculating the steady state of economic growth in Indonesia, from the data in 2022, we have N as population is 0.01 and delta is 0.08, and S as saving is we have 0.37, and G as technological progress or total factor production is 0.1, all data in percent. So we have a model Solow-Swan like this. Key star is 0.37 key minus 0.19 key. So after this, from the formula, so we can decide the steady state on the two factor, that is capital per worker on steady state and output per worker on steady state. In the table, we have interpretation. Steady state capital per worker shows a stable level of capital per worker at 28%, where investment is sufficient to cover capital depreciation and population growth. And the second, output per worker at steady state indicates a stable level of output per worker at 7%, whereas the economy is in long run equilibrium. And then for the result of the golden rule, we have for variable that is capital per worker golden rule, the result is 0.29, and the second is output per worker golden rule, the result is 0.69, and then consumption per worker on golden rule, the result is 0.67, sorry. And then the last we have saving on golden rule, and the result is 0.04. For the interpretation, for the result of the golden rule is capital per worker on the golden rule indicates the optimal level of capital per worker with minimal growth at 29%, where consumption per worker is maximized. Number two, output per worker on golden rule shows the output per worker in the golden rule condition with minimum growth of 69%. Number three, consumption per worker on golden rule show the maximum consumption per worker at 67% in the steady state. And then the last, the saving rate on the golden rule indicates the saving rate required to achieve the golden rule is 4% of the previous growth. So the last for my presentation is about the conclusion. That is, the Solow-Swan model is a powerful analytical tool for understanding the dynamics of economic growth. Using this model, economists and policymakers can formulate effective strategies to achieve sustainable economic growth and improve people's welfare. Understanding the role of capital labor and technology in this model is crucial in planning successful long-term economic policies. By implementing in the policy recommendation generated from this analysis, Indonesia can target economic growth of 28% for capital per worker and 7% for output per worker to reach a steady state, and can achieve the golden rule of 29% for capital per worker, 69% for output per worker, 67% for consumption per worker, and savings of 4%, so that Indonesia can create a strategy that can achieve higher and sustainable economic growth and improve the welfare of all its people. So that is my presentation about model Solow-Swan with technological progress, a case in Indonesia economic growth in 2019 and uh, until 22. Thank you for having us. Thank you for having me. Assalamualaikum warahmatullahi wabarakatuh.